Hello students, greetings to you all. Hope you all are safe and doing good. In last two classes, we were dealing with Unit 10 matter around us. Yes, and in today's video too, we'll be continuing with the same unit, and with this video, we'll be completing our Unit 10 matter around us. So let's move on to a motivational quote for the week. Study hard no matter if it seems impossible, no matter if it takes time, no matter if you have to up all night. Just remember that the feeling of success is the best thing in the entire world. Yes, my dear students, the fruit behind the success is the best ever feeling in the entire world. So study hard. It may be impossible for you. It may take time. You have to stay all night. But the success, the fruit of the success would be the best thing in the entire world. With this motivational quote, let's move on to today's class. Before that, we'll recap what we dealt in previous two classes. So we started with the chemistry unit, which is matter around us. So can we all recap the subtopics dealt in previous videos? Yes, first we saw about matter. What is the matter? Matter is anything that has mass and occupies space. Yes. So next is classification of matter. It is classified in two types. One is the pure substance and the impure substance. Pure substance is further classified into elements and compounds, whereas the impure substance is otherwise known as the mixtures. What are the types of mixtures? Which is homogeneous mixture and heterogeneous mixtures. In last video, we saw about the separation of mixtures, right? We saw nearly 6 methods on how to separate the mixtures. What are the 6 methods? It is solvent extraction method, centrifugation, sublimation, simple distillation, fractional distillation, and chromatography. Hope you all are clear with the subtopics which was dealt in previous classes. The topics to be concentrated in this session are just the two topics. One is the solutions and emulsion, and we are going to see the types of solution and the types of emulsions. So can we all move on to our class? Yes. So let's do a small activity. Take salt, milk, a flour. If you don't have flour at your home, you can use sand. Okay. Take these 3 ingredients. Have 3 transparent glasses like this. Okay. Have three transparent glasses. In first glass, mix salt and water. In second glass, pour the milk. In third glass, mix water and sand or flour, okay, whichever you have. What do you observe in each glass? So yes, in this video, we are going to briefly deal what we observe in these 3 methods, okay, 3 ingredients, mixtures. So yes, in today's class, we are going to see about the solution and the types of solution based on the particle size. So basically, solution is a homogeneous mixture. So let's take the first glass, which is a mixture of salt and water. Salt dissolves in water, right? Solution is a homogeneous mixture. Salt solution is a homogeneous mixture, right? The components present lesser amount by weight is known as solute. The components present in larger amount by weight is known as solvent. So in the first glass, which is the salt solution, which is solute and which is solvent. So here, salt is termed as solute, which is lesser amount, and the water, which is a higher amount, it's known as solvent. So solute plus solvent gives salt solution. Understood? Yes. Now let's see types of solution. In the first class, what was the procedure done in that? We took a water, we added salt in it, right? We added salt in it and it was allowed to stir well. Thus salt nicely dissolves with water and its final product was a salt solution, which is a salty water. So let's take the first glass, which is the mixture of salt and water. In salt solution, we get a clear solution, right? So there are some properties of salt solution. This is termed as a true solution. So first type of solution is a true solution. There are some properties like in salt solution we get a clear solutions, right? So first property is a clear solution, and second property is it is an homogeneous mixture, and third property is when we microscope the size of the particle, the size would be less than 10 power minus 7 centimeter. Okay, and the fourth one is components of true solution cannot be separated by filtration method. If we leave the salt solution undisturbed for very long time, we do not see any insoluble solid settles at the bottom, right? Thus, this salt solution, it is stable one. And it is an homogeneous solution, right? Since it has uniform composition throughout. And the solution will be clear and transparent. So these are the properties of a true solution. I hope you are clear with the true solution. So now let's take the second glass. The second glass contains milk, right? So second glass which has milk. As we discussed in previous classes, mixture, since when we look at it, it has uniform composition throughout, but if you take little amount of milk and observe it in microscope, it has varying particles like fats, calcium and so on, right? And so thus milk is actually a heterogeneous mixture. This type of solution is called as colloidal solution. So this colloidal solution has some properties like it is a heterogeneous system. So here milk is a homogeneous looking heterogeneous system, right? The second property would be it also cannot be separated by filtration method, and the particle size of colloidal solution will be between 10 power minus 7 centimeter and 10 power minus 5 centimeter. You can also try at home. Take a cup of milk and filter from the kitchen and filter the milk with the filter handle. Does anything stays in the filter? No, right? Thus it cannot be separated using filtration. The next property would be if we leave the milk undisturbed for very long time, we do not see any insoluble solid settles at the bottom. Thus it is also stable. The solution which satisfies these properties are called as colloidal solution. So let's take the salt solution and the colloidal solution. Mostly both the solution has the same properties. Both looks like homogeneous mixture, but we know that milk is a homogeneous looking heterogeneous mixture. So how to differentiate true solution and colloidal solution? Yes, the first best difference would be the true solution will be clear and transparent. So in case of salt solution, if you keep your hand behind the salt solution glass, we can see our hand clearly. But when we keep any object behind the glass containing milk, we cannot see the object. Thus, true solution is clear and transparent, and this property can be used to distinguish between true solution and colloidal solution. And the next important property to distinguish between true solution and colloidal solution is something which you would have observed in a dark room. Yes, if you have a dark room and open the ventilator or a small window, you would have seen the path taken by the light rays. This is because the tiny dust particles in the air, right? Tiny particles in the air. As the sun rays strike these dust particles, the light rays scatter. As they scatter, they take a wider area so that we can see the path taken by the light rays. This effect is known as Chindal Effect. So the scattering of beam of light by the particles is known as Chindal Effect. This same effect we would have seen in forest area too. I hope you all would have seen this type of effect in forest. Yes? Yes. So now how does this Chindal effect helps in differentiating true solution and colloidal solution? Let's take two beaker. One beaker contains true solution and another contains colloidal solution. It may be a salt solution and a milk, okay? So switch on the torch and allow the light to pass like this, okay? Switch on the torch and allow the light to pass in this two beaker. The path of the light rays become visible in colloidal solution. This is because the particles in colloidal solutions are big and it scatters the light rays and thus it is visible. But when we consider true solution, it cannot scatter the light rays because the particles of the true solution are too small and thus they do not have the property to scatter the light. Hence, Chindal effect helps in differentiating true solution and colloidal solution. Do you know who found this effect? It was discovered or observed by John Tyndall in 1989. He observed that when strong beam of light is focused on a colloidal solution, the path of the beam becomes visible. The best definition for Tyndall effect is the scattering of beam of light by colloidal particles present in a colloidal solution is known as the Chindal effect. Let's take a dark room again for an example. Let's observe the beam of light entering in a dark room. You will find that the dust particles are constantly moving in a zigzag manner. What really makes the dust particles move continuously? It is said to be a Brownian movement.
What makes dust particles move continuously in air? You already know that air is a mixture of gases, and gas molecules are always in a state of free random movement. These molecules hit the dust particles from all directions and make them move in an irregular manner.
Yes. In colloidal solutions, when we observe or view under a powerful microscope, we can see the colloidal particles are moving constantly and rapidly in zigzag direction. It is said as Brownian movement. Okay, so these are the two properties, which is a Brownian movement and the Chindal effect, which is important in the colloidal solution. So let us take the third solution, which is the sand and water mixture, or it can be a flour and water mixture. Okay, as we discussed in previous video, we know that sand and water mixture is an heterogeneous mixture and the heavier particle stays at bottom and the lighter particle stays up. It also has some properties. It is known as a suspension solution. Okay, and it has some properties like it is a heterogeneous mixture. It can be separated by filtration. Yes, we can separate water and sand by filtration method. In case of sand or flour, when it is undisturbed, the sand or flour stays below, right? Thus it is unstable. The particles of the suspension solution size would be bigger, thus the light rays scatter when the light is passed through a suspension solution. So these are the three types. What are the three types? First type we saw about the true solution. Second type is a colloidal solution, and the third one is the suspension. So can we compare these three types of solution? Yes. So we have suspension, colloidal solution and true solution. What are the particle size? First, particle size, it is greater than, for suspension it is greater than 100 nanometer. For colloidal solution it is 1 to 100 nanometer. For true solution it is less than 100 nanometer. When it comes to filtration separation, suspension, it is possible. Yes, we can separate the sand and water, right? So filtration process is possible in suspension. When it comes to colloidal solution and true solution, it is impossible. Milk cannot be separated using filtration and salt solution cannot be separated using filtration, right? And appearance of this solution. When it comes to suspension, the appearance will be opaque. For colloidal solution, it will be semi-transparent, and for true solution, we have the appearance would be transparent. The Tyndall effect will be shows when in suspension and colloidal solution, it will show Tyndall effect, whereas for true solution, it doesn't show Tyndall effect. And Brownian moment, suspension may show, colloidal solution may shows, and true solution may or may not shows. Okay, the nature of solution. For suspension, it is an heterogeneous. It should be an heterogeneous mixture. And colloidal solution also, it is an heterogeneous. But in case of milk, it looks like a homogeneous mixture, but it is also a heterogeneous mixture. Whereas for true solution, it is always a homogeneous mixture. Setting of particles, it settles on their own. Right? When we mix sand and water, sand settles bottom and water stays up, right? It settles on their own. Whereas for milk, when it comes to milk, using centrifugation process, we can separate milk and cream. We dealt in previous video, right? Whereas for true solution, it doesn't settle. It do not settle, okay? Thus, these are the comparison between the three types of solution. Hope you understood the difference of these three solutions. Now we move on to our next subtopic, which is emulsions. We know that solution is nothing but dissolving a solute with solvent gives a solution, right? But some doesn't dissolve with water, right? For example, water and oil. When we add together, it doesn't dissolve. They form two distinct layers since they are immiscible with one another. So here we are going to see the types of emulsions, and oil cannot mix with water. Why? Because it is a hydrophobic. The word hydrophobic, we'll split it as hydro and phobic. Hydro refers to water and phobic refers to fear. So oil is an water fearing. Hydrophobic refers to water fearing. The opposite of it is hydrophilic. Hydrophilic is nothing but hydro is water, philic is loving. So water loving. So salt and water is a hydrophilic, whereas oil and water is a hydrophobic. So let's move on to the types of emulsion. We have oil and water and oil. We cannot dissolve oil and water, right? But there's one binder known as emulsifier which makes the stabilize oil and water. Okay, here first one is oil in water emulsion and the second type is water in oil emulsion. Listen to this video carefully. It explains the types of emulsion which we use in our day-to-day life.
Everyday emulsions include milk, mayonnaise, ice cream, and paint. These emulsions are mostly oil droplets in water. Emulsions can also exist as water droplets in oil. Real-life examples include margarine, lotions, and facial creams. The world's most popular emulsion is, without a doubt, ice cream. The main ingredients are milk or cream and sugar, along with flavoring and coloring components. So what prevents an emulsion, such as ice cream, from separating? Substances known as emulsifiers are added to stabilize emulsions. When making ice cream, egg yolk is commonly added. The active emulsifier in egg yolk is called lecithin. Too little lecithin will cause the ice cream to separate, and too much will ruin its texture and flavor. All emulsifiers have two components, a hydrophilic or water-loving head and a hydrophobic or water-fearing tail. If we added lecithin to our original oil and water emulsion, its hydrophilic head will prefer to associate with water, and the hydrophobic tail with the oil droplets. This prevents separation and thus stabilizes the emulsion. In summary, an emulsion is a mixture of two substances that are miscible with one another. These emulsions can be stabilized by adding emulsifiers.
Yes. So what is an emulsifier? A substance which stabilizes the emulsion is said to be an emulsifier. We saw about hydrophobic and hydrophilic, right? So hydro means water and phobic means fear. Thus hydrophobic refers to water fearing, and when it comes to hydrophilic, hydro is water, philic is loving. So hydrophilic refers to water loving. So these are the three important terms in emulsions. Hope you all understood today's class. That's it for today's class. With this video, we completed our Unit 10, Matter Around Us. So can we summarize what we learned in today's class? Some points to remember. Yes. A solution is a homogeneous mixture of two or more substances. We saw three types of solution. What are they? True solution, colloidal solution, and the suspension. A colloidal solution is a heterogeneous system consisting of dispersed phase and dispersed medium. When colloidal particles are moving constantly and rapidly in a zigzag direction, it is known as Brownian movement. In colloidal solution, we saw two important properties, which is Chindal Effect and the Brownian movement. So this is what a Brownian movement. When a strong beam of light is focused on a colloidal solution, the path of the beam becomes visible. It is known as the Chindal Effect. And we saw about emulsions. An emulsion is a colloid of two or more immiscible liquids where one liquid is dispersed in another. What is an emulsifier? A substance which stabilizes the emulsion is said to be an emulsifier. Yes, so let's move on to the assignment part. As for the assignment, I'm giving a small activity to try it out at your home. Yes, so get a chalk piece, okay? Crush the chalk piece and make it as a powder, and take a glass of water in a transparent glass, okay? In transparent glass, take a glass of water and mix the chalk powder with water and pass the light using torchlight on the beaker. We would have seen the Tyndall effect, right? Torch was allowed to pass, right? Light was allowed to pass in the beaker. So this is what we are going to do now with the chalk powder, okay? Find out what type of solution is the chalk powder. We have three types of solution. What are they? True solution, colloidal solution, and the suspension. So find out what type of solution is the chalk powder solution. Okay, take the picture of the sample where you pass the light to the mixture and upload this activity in Google Classroom. So I have tried this at my home. I have pasted the picture of mine here. See here, this is what. But you are going to find what type of solution it is. Okay. For this picture, you will get 8 marks, and for the answer, you find what type of solution, you will get 2 marks. So this is a 10-mark activity. So try it at your home and give your best on it. Okay. Try to upload this activity in Google Classroom. Thank you, students. Stay home and stay safe.